Hello students, my name is Shashank Shekhar and today is the second lecture of the chapter Amines. So in the previous class we have seen the nomenclature and the structural part of the amine. In today's class we will be focusing on the methods of preparation. So if you talk about the nomenclature, so we have seen the nomenclature, also we have seen the types of classification in which we have primary, secondary and tertiary types of amine. Then we have seen the structure in which we have seen that the structure of amine is similar to your ammonia, only the bond angle varies. You can say all the bond parameter varies because the substituent, that is H, that is being replaced by an alkyl group. It has a say tetrahedral geometry and a pyramidal shape. Clear? Now let us today talk about the methods of preparation that can be used for preparing the amines. Tomorrow we will be seeing the physical and the chemical properties, in which we will be basically seeing the basic nature, means basicity. Of course, chemical properties involve all of these. And I would suggest you, so in the previous class I have made you see some of the heterocyclic amines. Now I would suggest you to order them according to their basicity. If you do not have enough knowledge, just try to use resources of your own and just try to order them and on the basis of their basicity. Okay, so that would be a help when we will be seeing the basicity, so that you can compare your ideas with my ideas. Okay, you don't have to do a new thing, you just have to use your old concepts of resonance and hyperconjugation in a different way depending upon the substrate that is being given, and accordingly you can arrange them in the order of basicity. There is nothing new. You will see that we do not apply in rocket science in that. It is simple, all the electronic effects that will be involved, and we will be classifying them as weak or strong bases. Okay, so today's class we will see the methods of preparation. We will take different type of substrate, react with appropriate reagents to get our final amine. So if you talk about the methods of preparation, so first we will take nitro compound and then we will reduce it using appropriate reducing agent to get our amine. Then the ammonolysis of alkyl halides means treatment of your alkyl halides with ammonia. Like our hydrolysis, it is similar to that. In hydrolysis we treat with water, in ammonolysis we treat with ammonia. Then the reduction of nitrile. So nitrile looks like this. See, triple bond N, and then alkyl is attached here. Then reduction of amides. So amides looks like this. Okay. Then we have Gabriel phthalamides. So I think this one will be the most important one. Then we have Hoffman degradation reaction. So let us see each of these. So first of all, the reduction of nitro group. So it is the nitro group. This is called as nitro. So what are we doing? We are taking a nitrobenzene and we are reducing it. Now how we are reducing it? We can reduce it in two ways. First of all, we can use the catalytic reduction, in which we have used H2 gas in the presence of finely divided palladium, and the solvent that is being used is the ethanol. Now you would ask, sir, can we use an aliphatic chain in place of this aromatic one? Of course, no problem. You can use that also. And upon reduction, catalytic reduction, you will get this NH2 here in this place. So it is reduction. Basically, you can see the oxygen has been removed. Simultaneously, the hydrogen has been added, and removal of oxygen and addition of hydrogen, both are termed as reduction. Now similarly, we can do the same thing with the help of a different reagent, that is SnHCl. Okay, so SnHCl, or you can use the Fe plus HCl, that is iron in hydrochloric acid or your tin in hydrochloric acid. This will give you SnCl2 and this will give you PCl2, and it will further reduce this nitro group. Now this only requires a very small amount of, say, hydrochloric acid to initiate the reaction initially. So it is just a kind of initiator. You don't need a say large amount of this HCl. You need a catalytic amount of HCl to convert this nitro group into ammonia. Sorry, amine, or more appropriately, aromatic amine. Now next is the ammonolysis of alkyl halide. So this reaction goes like this. So it has a certain mechanism. So what do? First of all, we take a ammonia, okay, and we treat it with your alkyl halide. Now you must have seen the structure. In the structure you have seen that ammonia or any other amine has a lone pair on it, because there are 5 electrons. 3 of them are involved in bonding with H, 2 are free electrons, or you can say lone pairs. Now this bond, or you can say this compound, that is Rx, is being polarized because this X is halogen and it is more electronegative. So there will be a delta negative charge on this thing and a delta positive charge on this thing. Okay, so since there is a positive charge and we have negatively charged electrons, that is the lone pair, so this lone pair will attack here and this X will be kicked out. Now this goes through a series of you can say steps. First of all, we have one NH3 that kicks out this X and we get this thing. So this is for simple ammonia. Okay, or you can take another type of say substrate. Suppose we take a primary amine, we treat it with Rx. So first N will just kick out the one X and take the R. So we have 2 R2NH, and 1 hydrogen is left. Again, 1 nitrogen will again attack this R, X will be kicked out. You will be left with this R4N plus X minus. Now this both are ammonium salt. This is substituted ammonium salt, in which say this is ammonia and one of the substituent is R, and this is quaternary ammonium salt. Okay, now this all or both of this can be further hydrolyzed to get our final amine. So the reaction is carried out in a sealed tube at 373 Kelvin. The primary amine thus obtained behave as a nucleophile and can further react with alkyl halide to form secondary, tertiary, and finally quaternary ammonia. So what it is written is that, so as we do this, so after this we will get this RNH2, primary amine. Okay, now this primary amine will further react with another mole of Rx and it will end up at this point. Okay, it will end up at this point, means you will start the reaction from here. It will give this thing. This will be further converted into this RNH2. It will react with Rx, then again 1 mole of Rx and again 1 mole of Rx. So how many mole of Rx are involved? So you can see 1, 2, 3, 4 to make this quaternary ammonium salt. Now this process of cleavage of CX bond by ammonia is called as ammonolysis. So this is basically the reaction of ammonia with Rx. So it is called as ammonolysis of halogen or haloalkane, I would say. Okay, clear? So this is one of the methods. Now what is the next method? The next method is reduction with nitriles. So what do? Is we take a RCN. Okay, now here 2 methods are possible. One of these is this one. So I will not talk about the mechanism of this. You can just look at this reaction. We have to use the H2Ni, and in the presence of NaHg and C2H5OH, we have reduced it to RCH2NH2. Now if you think about the mechanism, it is simply a catalytic hydrogenation reaction. There is no mechanism to follow. But if we take LiLH4 rather than this catalytic reduction, then what will happen? Think about it. So what will happen in this reaction is that there is a LiLH4 which is a hydride donor. Okay, so if you look at the structure of this, it looks like this. Okay, LiAlH4, it has one negative charge on it and an Li plus and a LH4 minus. Now this H can be donated to groups that are electropositive in nature. So we have this RCN. Nitrogen is electronegative element next to say fluorine, oxygen and nitrogen. So delta negative and delta positive. So that H minus will now attack here. So that would result in, so we have this thing, we have A, L, H, H and H. So it will attack here and you will get a negative charge on this. Okay, so RCH and N negative and one double bond. Now we have a solvent that will provide the H and it will be RCH NH. Now if you treat it with water, since this reaction is done in the presence of water or H2O, this amine, this is called amine, and if you have attended the previous classes, then you must have seen that upon hydrolysis of this amine, we quickly get this say our aldehyde. This can be one product. Now if we do not take H2O as the protic solvent and take another solvent, then in that case one more H will be donated here and it will result in RCH2NH2. Okay, no problem. So in this 2 moles of LiLH4 are involved to convert your nitrile into your final RCH2NH2. That is your amine. Now this reaction is used for the accent of amine series, that is for preparation of amine containing one carbon atom more than the starting amine. So what it is written? That it is used for the preparation of amines containing one carbon atom more than the starting amine. So it has one more carbon atom here. Clear? So these are the 2 methods. First of all, we can use this catalytic hydrogenation or we can use LiLH4. Both are good. You can use both of them. But the problem with this reaction is you can only produce primary amine. Why is it so? What is the reason behind it? Think over it. Because you can see that this nitrile has only one left valency, that is alkyl group. Only one alkyl group can be attached because this nitrile 3 bonds are already with this nitrogen. Therefore, it is a 1 degree carbon. Now, no matter which reduction method we utilize, we cannot change the number of R group that is being attached to this carbon. Therefore, it will result in a primary amine only. And not only in this methods, in the upcoming methods, you will see that most of the methods are appropriate for primary amines only. Next, after nitrile, we can also use amide. So this is the structure of amide. It is a derivative of your carboxylic acid in which we have replaced OH with NH2. So if similarly, we can also use here LiLH4. You can use LiLH4 here also. Now what will happen in this reaction? How this reaction will go? So let us just try to do the mechanism of this reaction. So we have a RCONH2. And we are told that upon reaction with LiLH4 first of all, and then H2O will give us R CH2 NH2. So in the first step, what will happen? This LiLH4 will donate this hydride on the carbonyl center and reduce it to this kind of group. Okay, here we have NH2 and here we have H. Now what next can happen here? Okay, what next can happen here? So in the next part, what will happen is that the water will donate one H here and will form OH2 because it is very unstable. This both the amine and the hydroxy group on the same carbon is very unstable. So this will create this kind of intermediate and now it will quickly donate electron and will remove this thing to give RCNH2 plus. Okay. Now in the further part, what will happen? Again, one LiLH4 will donate one hydride here and one H will be added here. So this will be the course of reaction that will be followed to give our final product. Okay, clear? No problem. So in this way, we will get our RCONH2 to RCH2NH2 in the presence of LiLH4 and H2O. Now next. So I think this is the most important method. You should be aware about the stoichiometric coefficients also through each of these reactions. So this reaction is only appropriate for primary amine. Similarly, the previous reaction also was only appropriate whether you talk about nitrile or you talk about amide. You can only prepare the primary amine using all of those, because if you look at the structure of those, only one alkyl chain can be attached to the alpha position of the amine in both of this case. That is this one. So only primary amine is possible. Here also you will see that through the mechanism that only primary amine is possible. So for this, what do we take? We take a phthalimide. Now I would ask you how you would prepare this phthalimide. You must have seen this reaction earlier right now. Okay. So if you remember those reaction, in the reaction of your say carboxylic acid, or if you can say your phthalic acid, if you take a phthalic acid, okay, and you treat it with NH3, what will happen? This will create COO minus and NH4 plus. Okay, here also COO minus and NH4 plus. Now it will be further converted into amide upon hydrolysis. Okay, now this will attack here and it will kick out this thing in the form of ammonia, and you will get your phthalimide. So this reaction was there in the previous say class when we were say reading the last lecture of the aldehyde ketone carboxylic acid, in which we are seeing the reactivity of the carboxylic acid. So there we saw this reaction. So we use the same reaction to prepare our phthalimide. So it is a derivative of your phthalic acid. The phthalic acid looks like this. We have positioned dicarboxylic acid. So what do? We treat our phthalimide with KOH. Now what is KOH? It is a base, and this hydrogen is vulnerable for abstraction. So this KOH OH minus will abstract one hydrogen from here and will make it N minus and K plus. Now this nitrogen has a negative charge on it. If you treat it with RX, this will attack the R and will kick out the X to make your N-alkyl phthalimide. So it is a derivative of phthalic acid only, in which we have created a phthalimide, and it is N-alkyl because this N-alkyl is for NR. Now on treatment with NaOH, if you treat with NaOH, this will create this kind of phthalic acid, or you can say phthalate ion. OH minus will attack here and will kick out this bond from here. Similarly, OH minus will attack here and will kick out this here, and we will get RNH2. So if you look at the mechanism, it will go like this. So you have this thing like this, NR. Now the answer why this primary amine is only possible lies in this mechanism. You can see here that this nitrogen is now attached to only one R, and no more R can be attached here. Okay, no problem. Now the OH minus will attack here. And we'll kick out this thing. To make it as O minus. And this H plus will be transferred onto the amine. Sorry, the nitrogen. Again, one more OH minus will attack. And we'll kick out this thing. So in this way, you will get your phthalate ion. Along with this phthalate ion, you will also get one NH2R. That is your primary amine. Okay, this is your primary amine. Now, sorry for one mistake which I have done earlier, that okay, nitrile cannot be converted into any secondary or tertiary one, but amide can be, because in case of nitrile, nitrogen cannot have any H replaced, cannot have any H replaced, but in case of this amide, we can have say 2R attached to this. Suppose not 2R, 1R I would say, and that would on further reaction with LiLH4 would result in a secondary amine. Okay, so this was the preparation of amine with Gabriel phthalimide synthesis. Next is the Hofmann degradation reaction. So this reaction is unique. We will see why. Why is this reaction unique? We will see it. So in this reaction, the equivalents are very important. So what do we do in this reaction? We take one equivalent of amide, treat it with one equivalent of bromine, but in the presence of 4 equivalent of sodium hydroxide to get one equivalent of amine, one equivalent of sodium carbonate, and 2 equivalent of sodium bromides and 2 equivalent of H2. Now, why do we call it degradation reaction? So if you look at the reaction carefully, you will see that we are removing one carbon from this amide. So this carbon is now being removed, and we are getting an amine that is having one carbon less than the parent amide. So for this reason, we create, or you can say this is a kind of degradation reaction. So this important point should be kept in mind, that whatever amide we take, the product that is formed will have one less say carbon, one less carbon as compared to the amide that we have taken. Now let us move to the say our mechanism, because because this reaction looks quite peculiar to look at. So we will look at the mechanism also. So what is the mechanism that can be expected? Okay, so what is the mechanism that can be expected? So let us look at the mechanism. So first of all, we have our amide. This is our amide. Okay, so we are treating it with NaOH and Br2. So first of all, this OH minus will take one H from here. It cannot not do anything else. So you just try to think of it. OH minus cannot react with Br2 as it has no acidic proton, but since it is a base and this hydrogen is susceptible to your abstraction, therefore it will abstract it. So after abstraction, you will get this kind of thing with a negative charge and a Br2. You have a Br2. Now this negative charge will attack this Br2 and kick this Br out. Okay, so that would result in RCO and Br and H. Okay, now again we have an H here. Again one OH can be implied and this H can be abstracted, and in the next part we'll get a negative charge. But now you would think that it will again attack one Br2. No, it will not do so. So this reaction is not that much simple, because this reaction involves the formation of a special type of rearrangement product that is termed as say cyanito. Okay, cyanito, we'll look at this. So what will happen here? So first of all, this Br will leave by its own and create a nitrene. Nitrene will be created here. So nitrene will look like this. Okay, this nitrene will look like this. And now what will happen? A rearrangement will occur. This will go here and this R will travel here. So simultaneously both of this step will take place. So we have O, C, N and R. Now this is called cyanito. Cyanito, I would say. This is called cyanito. Now what will happen in the next step? We have OH minus again. So you have a OH minus that will attack here and will create this thing. This pi bond will move here and we will have OH and also N, R. Now this charge will come back and will put this pi bond here. Okay, this will put this pi bond here and we will get C double bond O, N negative, R, OH. Now there will be an interproton transfer. What will happen? There will be interproton transfer and the hydrogen from this oxygen will be transferred onto this one. What will happen? The hydrogen from this oxygen will be transferred onto this one, and further this negative charge will resonate and kick out this NHR, releasing CO2 gas. So the release of CO2 gas is the basic driving factor in going through this complex mechanism. Okay, so we end up with this kind of thing in which we have one R here, one H here and one negative charge here. So this OH minus, which has taken H plus earlier, will again donate this H plus. And will give back the OH minus, because this is a base catalyzed reaction. So we will get at last NH2R. This is a primary amine. But you can see that the carbon has been kicked out. One carbon has been kicked out in the form of CO2. So through the mechanism, you can look that why this CO2 has been kicked out. So what are the byproducts that are formed? So you must have seen that Na2CO3 is formed. So this NaOH react with the CO2. So you must this CO2 that has been released, that react with NaOH again. Basically CO2 react with NaOH to give Na2CO3 and NaBr also, because each time NaOH reacts, OH is being removed and Na is being left, and that will form the Br. 2 moles of water. So each time this OH takes one say H plus, we will form one H2O. So you can see here, so there are 4 NaOH initially and 2 NaBr are formed, because the remaining 2 Na are being transferred here and the OH minus takes one H plus to form H2O, 2H2O. Now this is the overall reaction. Now the main thing that is to be remembered throughout the reaction is that you are doing a reaction in which the amide is being reduced to your amine. No problem, you have done this with the help of LiLH4, but the difference is that you have removed one carbon, one carbon is now less than the initial amide. Also, some of the points that you should remember is that its mechanism is not so simple, it is so complex. So in today's class, we have seen various methods that can be used for the preparation of amines, starting from the reduction of nitro group, ammonolysis of alkyl halides, then reduction of nitriles, reduction of amides, and Gabriel thalamide and Hoffman degradation. Now, if I talk about something about each reaction, then I would say that primary amine can only be produced using nitriles reduction and Gabriel thalamide process. This one thing. And second thing, Hoffman bromide degradation, bromoamide degradation results in a amine that has one carbon less than the initial amide. That is this one. So this is the preparation method. Now, in the next class, we will see the physical properties first of all, the physical properties of amine, and then the chemical properties of amine that would involve the basicity of amine. So similar to our acidic nature of the carboxylic acid, in which we use pK, this amines will also have a pKb, and we will use this thing to and fro for defining our basicity, or using a much easier scale for defining the basicity. So with this, I would end my lecture. Thank you.